Muy buenas tardes a todos. A nombre de la Universidad de Ciencias Aplicadas y Ambientales, la UDCA, agradecemos la presencia de todos ustedes en esta charla intitulada Puntos de Inflexión, ¿qué son y qué papel desempeñan en nuestros sistemas actuales? Con nuestra invitada especial, Sally Thompson. Sally es geógrafa por la Universidad de Bangor, Reino Unido. Durante su formación realizó una pasantía en India con una ONG de desarrollo comunitario, investigando las percepciones juveniles sobre la igualdad de género. Cuenta con una maestría en Global Sustainability Solution de la Universidad de Exeter, donde desarrolló un gran interés por los sistemas alimentarios sostenibles, los puntos de inflexión y los bucles de retroalimentación de los sistemas socioambientales. Durante su investigación de maestría en colaboración con Devon County Council, evaluó el impacto de proyectos comunitarios locales utilizando la metodología Most Significant Change. Posteriormente trabajó como investigadora en la Universidad de Nottingham en la organización Right to Freedom. Sally es activista ambiental y promotora de la sostenibilidad en Reino Unido y actualmente se encuentra voluntariando y aprendiendo en fincas de permacultura generativa en Ecuador y Colombia, donde profundiza en prácticas agrícolas sostenibles y en el vínculo entre regeneración ecológica y bienestar comunitario. A continuación, le damos la bienvenida a Sally Thompson para su presentación. Al finalizar la charla, abrimos un espacio para preguntas y comentarios, por lo que les invitamos a participar a través del chat. Sally, el floor is yours.
Perfect. Thank you so much, Bruna, for that lovely introduction. Yeah, I'm going to switch to English now. I am working on my Spanish, but unfortunately, it's not quite at a point where I can talk about tipping points in great detail. But thank you so much for having me. It's really, really nice to be here and be able to share with you what I've learned over the past few years. As Bruna says, I'm come here from the UK and I am traveling in South America for a few months to put the knowledge that I've learned about regenerative agriculture and sustainability into practice on farms in Ecuador and Colombia. But I have a sustainability background, so I did my undergraduate degree in geography in Wales, which is where I met the lovely Bruna, and then went on to do my Masters in Global Sustainability Solutions at the University of Exeter. And I put this one in bold on my slide because I would say that's the most relevant and brought me to what I'm doing today, and it's where I got most of the knowledge and content from that's going to be in this presentation. Having said this, this research that I'm going to be covering is things that I've studied, but it's not necessarily data that I've collected personally. And I've done extensive research into the topic, but there may inevitably be questions that I might not be able to answer, but I will try my best. If I don't know the answer, I do have strong connections within the Global Systems Institute at the University of Exeter, so I can connect you with the people who have done the research themselves, and I'll show you some of those people at the end of the presentation. But yes, I will do my best. I'm also going to get a big wave from Bruna if I start speaking too quickly for the translation, but if there are any issues, please just let me know. So yeah, I'll just get started then. So as Bruna said, this presentation is going to be about global tipping points, focusing on their relationship with our current and our future climate. So I'll just go there. So we're going to start just by setting the scene, essentially, looking at the recent and more historic climate records, then looking at the basics and in more detail of what a tipping point actually is, and then looking at feedback loops, which are mechanisms that drive or affect tipping points. And then we're going to look at mainly at examples of negative tipping points that we're approaching, specifically the Greenland ice sheet and the Atlantic circulation. And I'm aware that a lot of this presentation might be a bit alarmist and doom and gloom. So we're going to end on a more positive note and look at how we can all have a sense of empowerment and feel like agents of change to to create more positive tipping points to try to mitigate some of the issues that we're looking at for the majority of the presentation. And I will stop for questions, but also I assume we might have questions like all at the end, but if there's any burning questions, please do like raise your hand or put something in the chat. So just to start, I'm just going to look at a quick video, which, I mean, you probably will already be familiar with this because everyone at this point is aware of the warming climate, but this just is a nice visual representation of the changes and the gradual warming that we're seeing in our climate since like the late 1800s to nearly to present, although this is a few years old. So as you can see, we have some oscillations in temperatures, but then as we're approaching the late 1900s, early 2000s, we see clear warming globally, but then more specifically within the Northern Hemisphere. And if I can pause it at the right moment here, I don't know if you can see here that there's like what we call like a cold blob, I think seems to be the scientific name for it. And we're going to look at why this is there and why we have this anomaly in the Northern Hemisphere. This graph here is just looking at, in the past 400,000 years, carbon dioxide levels. So you can see that they have fluctuated, but now we have reached a level that we haven't seen before, and it seems to be constantly rising. And as a result, we are exiting the stable climate that we've had during the Holocene period and now entering what we're calling the Anthropocene, because we're seeing climate change that's caused by humans and it's never seen before. And as a result, it's having implications that we hadn't foreseen and that are incredibly complex. So we're trying to look at some of those now. So this, like, bear with me, I realize this is a really weird video. I was shown this in one of my first lectures during my master's, and it's just really stuck with me. I promise there is a purpose to it. As you can see, it's called Leadership Lessons from Dancing Guy. To provide some context, this is a party or a festival in Germany, and I'm using it as an example to show a simple example of a tipping point and how this kind of in a social context, we can go from one state to another in the period of just a few minutes, basically. So I'm going to quickly mute this. Oh, it's muted, perfect. So in the start of this video, what we have is what you could call a stable state, where the majority of people at this festival are all just, you know, chilling on the grass. They're just having a nice time. But then we have one person who is being what you could say is weird behavior, and he's having his own party. And at first, people didn't really want to join in because he was the odd one out. But then now we have this really important second person who is becoming what we would call an agent of change, and he's creating enabling conditions to transform this context from a stable state of everybody just being chilled to suddenly a growing group of people having a party, I guess you could say. So it's just those two for a bit, and some people are still like, oh, I don't know if I want to join them. I don't know, it's still a little bit weird if it's just me and two other guys, and then I'll just speed up. But then before you know it, we've got, you know, I think the dancing just gets weirder and weirder as people get more confident. And then after you have those few people who start to join in, it starts to have this snowballing effect where the more people who are dancing in a crazy way, the more people want to dance, because suddenly that's where all the fun is. And because of this snowballing effect, what we'll look at in a minute in a more simple diagram is it's got to the point where even if you took out that first dancer or even the first two dancers out of the equation, the party's still going to keep going. And obviously it could stop if the police came and like told everyone to shut up and sit down again. But if that doesn't happen, one of the only, like, it just like is limited by the number of people at this party or at the festival who are going to go and join in. So this is just a more silly example of a change of state in a short period, and how you can have what we could call social contagion, where you have a growing number of people doing a new thing. So what is a tipping point? So that was more of a social example, but I'm going to just start by looking at it in the context of climate science, because that's what we're going to be doing, mostly looking at in the presentation. So in the context of climate science, A tipping point refers to a critical threshold in the Earth system or related processes. If these are passed, it can cause sudden, dramatic, or even irreversible change to some of the Earth's largest systems, which we're going to be looking at. Drawing this back to social tipping points as well, there's a lot of similarities, and I would say the three common qualities or themes or characteristics which emerge from many tipping points is firstly the abruptness of it, so it can change extremely rapidly and go from one state to another. Obviously, social ones are perhaps quicker than some climate ones, but there's that element of abruptness that's quite common. Self-perpetuation, so like I was saying before with the dancing, once we got like enough people, usually for a social change, you need at least like 25% of the population to be doing it to enter the new state. It becomes self-perpetuating, you have a snowball effect, and it just keeps growing and growing. And this does depend on the tipping point, but the last one is irreversibility, particularly with climate ones. Once you've entered a completely new state, it can be extremely difficult, if not impossible, to reverse it and to go back to the new state. So these are just some characteristics to bear in mind as we go on. So this is just a simple diagram to kind of illustrate what we saw in the video. So we have the party is of being the ball is in the first curve, and it's quite stable because the curve is quite deep. And then you have one person who starts to tip the ball closer to the edge. And then as you see with the green figures, you have more and more people working together as agents of change, getting it over the point. And then it gets to the point where there's a snowballing and the ball just keeps going down until it gets into the next stable state. And it's not so obvious on this picture here, but something to bear in mind, especially with climate tipping points, is this idea of resilience. So so you can see that the curve goes from being more dipped to less and more flat. And this is important because in climate tipping points, when it's in a state with a bigger dip before we start going towards the tipping point, we say that it's more resilient because if it's in a bigger dip, it is less likely to be moved from one side to the other. And if it is going towards the tip, it quickly goes back to the state that it was already in. But once you start to change the context of what's happening and the dynamics of the system, that curve becomes more and more flat. So it is much more likely to go over the point of no return, you could say. If it does go back to its original state, it just takes longer. Breaking this down even more, again, here you can see with the gradient of colors, what I was just saying about the curve changing shape. But what we're adding here is the presence of feedback loops. So when we have the system in its first state, we have what you could call reinforcing feedback loops, also known as positive feedback loops, but not positive in the sense of emotionally positive. It's just the idea of something being amplified. And then, balancing feedback loops, on the left, having a dampening effect, and then reinforcing ones being amplified. So the balancing feedback loops keep a system stable and keep it within the first curve. Once the curve starts to change shape, those feedback loops generally become less and less effective, so they can't keep it in their place because all of the context is changing. And then once you get over it, you have those reinforcing feedback loops that cause that snowball effect and cause the ball to keep rolling down until the new state, and then we'll have new balancing feedback loops in place. So looking at an example, a real world example, stepping into the climate side of things now, one positive or reinforcing feedback loop that we can look at is the Amazonia dieback. So just starting from the top right, so we have increased global mean temperatures or global warming, which result in a decrease in rainfall levels and increase in drought stress across the Amazon. And this can lead to an increase in the dieback of Amazonia vegetation because of drought stress. And this graph looks at the image looks at the consequent increase of emissions released from the dying Amazon. and CO2 and other greenhouse gases. But also to add is that the dieback results in reduced evapotranspiration, resulting in a reduced rainfall, leading to more drought. So we have a less stable system. And overall, this snowballing effect due to the introduction of increased global warming is going to cause continual Amazon dieback unless there's some kind of intervention in place. This one is a more basic graph I've just put together, diagram, which is a negative feedback for mangrove growth and carbon storage. So as we see increased levels of CO2 in the atmosphere, we see a consequent increase in temperatures and a warmer climate, which is more hospitable or suited for mangrove expansion because they like those warmer climates, which increases the absorption of CO2, which means that we reduce the amount of CO2 that's in the atmosphere. So instead of accelerating the CO2 and accelerating the warming, it kind of like negates itself and it's in a stable position. Now onto the major global tipping points. So up to 15 tipping elements are now deemed as active by climate scientists. These are some of the ones on this map that are deemed to be the most concerning and are approaching a tipping point, or arguably, or some people argue that they already have passed them. So recent studies have suggested that warming of 1.5 degrees, which we've already surpassed, could trigger multiple tipping points. And there's argument that the Greenland ice sheet and the West Antarctic ice sheet may already have passed it at 1.1 degrees. It's hard to say this with complete certainty because the effects of it can be quite delayed and there's lots of different ways to measure it, but there's real concern that we've already passed it and that we'll see the implications in decades to come. Obviously, there's too much to look at here in one presentation, so I'm going to mainly focus on the Greenland ice sheet because this is so close to the tipping point and it can affect lots of other tipping points and Atlantic circulation. One more thing to note is the arrows here indicate connectivity because in many cases, you don't just have one tipping point. We have what you call coupling, where one can trigger the onset of another tipping point. And in a completely worst case scenario, we can have what is called a cascading of tipping points, where you have a domino effect, where they all trigger, one triggers many tipping points. But that's worst case scenario. We're not going to look into that in great detail today. Yes, and just looking at this diagram as well from the IPCC assessment report. So this graph is indicating that the assessed risk of these tipping points being reached is becoming higher and higher, like every year. So compared to 2001 to 2022, the perceived likelihood that we're going to reach these tipping points is now considered to be low, between 1 and 2 degrees, whereas before it was considered to be low by around 2 to 3 degrees. And the case with high, now we're seeing between 2 and 3 degrees is a high risk of reaching these tipping points. And we're already near that range now. So it's quite alarming. And the risk assessment changes for many reasons, because of the changing climate, but also because we can access new data. And because we have these coupling tipping points, there's effects that one system change can have on another that are really hard to predict. So that's why the risk assessment keeps changing. But yeah, so it's just to bear in mind that these risks really aren't static and there's constantly new information coming in. So focusing now on the Greenland ice sheet, I just wanted to put this in the context of feedback loops. So one, I guess I'll start with the right, one of the negative feedback loops that we have keeping the system stable, or previously that's been keeping the system stable, just a small example, is when we have a colder climate, we have the presence of increased snowfall, which increases surface albedo. So there's less reflection of solar radiation because we have like a bright white surface, which reduces the surface melt of the ice sheet, increasing thickness, decreasing surface temperature, and helping to maintain that cold climate. So systems like processes like this have been keeping the maintenance of the system. But now with global warming, we're seeing more of this positive feedback. So we have increased temperature, which increases snow and ice melt. And because of this, those darker surfaces are being revealed. So we have a reduced albedo, so more radiation from the sun is being absorbed, and we're increasing the temperature of the waters, so we have more snow and ice melt. And then it just keeps going until we remove the whole ice sheet because it's melted. So this is kind of the systems we're facing with the Greenland ice sheet, and then just putting this back in the context of the diagram we had earlier. So this one, the negative feedback loop, is the one that we were looking at, which is the context for the feedback loops that are maintaining it in this part of the diagram. And then we have the positive one, which is causing this snowballing that's going all the way down to the new system. But obviously there's many feedbacks. These are just examples. So why is the ice sheet so unstable? So since the Arctic is currently warming about 4 times faster than the global average, the ice sheet is being exposed to both increasing air temperatures and also changeable weather conditions, including an alteration in cloud coverage. The rate of melting that we're seeing, so one study has suggested that at 10 meters depth, there's been an increase of about 0.7 degrees per decade in the period of 1985 to 2022. That's looking at ice cores for the data. And the early warning signals, so why do we think that we are approaching a tipping point and not just seeing melting? So some of the main ones are the rate of increased melting and runoff from the ice sheets, the increase in the discharge of solid ice that's going straight into the ocean, and the reduction in the height of the ice sheet. So all of these happening together and at such a high rate are what is setting off those warning bells for approaching the tipping point. And there are 2 tipping points really with Greenland ice sheet that we have identified as being potential. The first one that we reach is if we have more than about 1,000 gigatons of carbon dioxide being emitted. This would potentially melt the entire southern part of the Greenland ice sheet in the long term, which would cause about 1.8 meters of sea level rise. And for context, about 500 gigatons had already been emitted, or when this paper was released in 2023. And if we surpass this, if once 2,500 gigatons of carbon are emitted, it would eventually melt the entire ice sheet, which would cause about 7 meters of sea level rise, which would have catastrophic consequences. It's important to note the timescale for this is hundreds of thousands of years, maybe hundreds of thousands, we don't really know, but it would be extremely difficult for the ice sheet to then grow back after this period. So it may be a long time in the future, but the more melt that we see, the harder it is to get back to that first state because of what we were looking at earlier, which is that aspect of irreversibility. So it's important to act on this and to try to reduce carbon emissions to avoid these amounts of sea level rise. Moving on quickly just to the AMOC. So this is the atmospheric meridional overturning circulation, which you could kind of see as a conveyor belt, which brings warm water from the subtropics into the northern hemisphere, where once the water rises and cools and sinks, becomes more dense, it goes back to the bottom. This is a part of the Atlantic circulation, which is what it was called on the map of tipping points. So AMOC is a key part of it. And we're looking at this because it's a particularly high risk of collapsing. And that is a problem because the AMOC is really important for stabilizing the world's climate. So because of where it is, it keeps one hemisphere warmer and one hemisphere cooler. So it's the main reason why the northern hemisphere is 1 to 2 degrees warmer than the southern hemisphere. And just a fun fact, it also transports more heat to the north than 50 times the total energy use of humanity combined. And in the past few millions of years, the biggest and most abrupt climate changes to occur were in the North Atlantic. And we're going to see how that's affected by the Greenland ice sheet historically in a minute. Just a quote to add from the 6th IPCC report, which is saying that while there is medium confidence that the projected decline in the AMOC will not involve an abrupt collapse before 2100, such a collapse might be triggered by an unexpected meltwater influx from the Greenland ice sheet. So, and this is because the influx of the fresh water, which isn't saline, it alters the salinity of the water in the current and the density of the gradients of the current, and it interferes with the process of the deep convection. So going back, so what basically it's saying here with that the collapse might be triggered is just looking at these maps. So this is kind of an unexpected change. So when there was a simulation for what the Earth might look like if we had 1 degree warming, it looks different because you don't have what we were talking about earlier, which is the cold blob. And the cold blob is what's caused by the AMOC. So when you factor in the Greenland ice sheet, that's when it starts to make sense as to why the observed changes were different to the simulated changes. And we have seen this relationship or this interaction before historically in the last glacial period, where the melting of the Greenland ice sheet unexpectedly affected or strongly weakened, that's a juxtaposition, significantly weakened the AMOC. So during the glacial period, there was an extreme warming of the Greenland ice sheet, and then this big influx of fresh water weakened the AMOC and reduced temperatures in the northern hemisphere. So we know that this relationship exists, and then it can happen again. It's important to note that, well, you can note that it does have, because we're taking the temperature away from reducing it in the north and taking it to the south, you can say that means that the AMOC will have a cooling effect on the Greenland ice sheet once that water is diverted to the south, the warmer water. But in our current trajectory of warming, and what we're looking at is not just a weakening of the AMOC, but potentially a complete collapse. So in this future trajectory that we're looking at, this cooling effect, the potential cooling effect, would not be enough to restabilize the ice sheet. So we can't count on it as our saving grace. We can't say, oh, it's okay, because once the AMOC collapses, it will just fix everything, and then the ice sheet will regrow again, because that's just not true. So because we have other factors to bear in mind, which are exacerbating with as global warming is increasing, such as the warmth of the ocean around it, the levels of sea level rise, and the general loss of glacier stability. So this will continue to shrink the ice sheet, even if we have this cooling effect. In terms of where we currently are at with the AMOC, the risk level that we can see, the current median estimated warming that is thought to be required to surpass the threshold of the AMOC tipping point is approximately 4 degrees above pre-industrial levels. Obviously, this is a median, so there is there's a range of it, but we are already quite close to this, so it's like worth bearing in mind that we're approaching the tipping point. And some more information from the 6th IPCC report is that even in a low emissions scenario, so if we're being optimistic about how things will turn out, the AMOC is projected to weaken between 4 to 46% by the year 2100. And then in a high emissions scenario, it's between 17 to 55%. So it's, yeah, the definite indications that things are going to be changing potentially quite soon. And another early warning signal for the weakening or the collapse, particularly the collapse of the AMOC, is not just changing in the Greenland ice sheet, but also a loss of convection in the Labrador Sea, which is a whole other thing, but just to bear in mind as well, that there's different ways to see it. So I just wanted to do a quick summary of what feedbacks we can see that are involved in AMOC. Firstly, the feedback involved in keeping it in its equilibrium state, and then the reinforcing feedback that's causing us to approach this tipping point. So in its equilibrium state, we have the salty water, which is brought from the subtropics, which increases the amount of water that's sinking because of the high density of the water, which then promotes or continues the deep convection that we need to keep the system going, which then brings in more salty water. So it's like a closed loop, and it keeps going round and it keeps everything ticking. And then on the right, as soon as we have our changing climate and increasing temperatures, we see an increase in the meltwater influx from the ice sheets, which then reduces the density and the convection, which then contributes to a even more changing climate. So this disruption is what's one of the things that's starting to get us closer to the tipping point. And it's this meltwater influx that hasn't historically always been taken into consideration when we've been doing climate models for what the AMOC's collapse might look like. So looking just more broadly at some of the global implications, I've already mentioned that we'll have a shift in warm temperatures, but what does this actually mean? So it means that we'd project to see a drier northern hemisphere and an increase in tropical rainfall in the south. So those monsoon rains that we're used to seeing in the in the north will suddenly move, which will have a large impact on those areas that rely on that. We'll have water shortages in areas like in the rainforests where we don't usually, and this will have a knock-on effect to like agriculture and drought, which we'll see more specifically in Colombia in a minute. But also not just the change of rainfall patterns, but also an extreme drop in temperatures across Europe because of where that cold current is going to be moving to, when we're going to have those colder waters. And in places like Norway, we'll potentially see a decrease of 20 degrees in average temperatures across the year. So we're going to have like an extreme change in weather conditions. And also just to bear in mind winds, which are driven by temperature gradients. So we're going to likely see an increase in stormy weather extremes across Europe. And yes, more specifically in Colombia, we need to bear in mind the role of the ITCZ, which is the Intertropical Convergence Zone, which is a band of rainfall that's near the equator. And the collapse of the AMOC would cause it to shift southward. So we would have dry conditions in northern Colombia and the Caribbean region, and we'll have leading to droughts and agricultural stress in the long term. And another tipping point can be affected by this, which is the rate of Amazon rainforest dieback, and therefore the consequent increase in release of carbon. Hotter sea surface temperatures off the Colombian coast can also intensify heat waves, hurricane activity, and coral bleaching and marine ecosystem stress. So this would affect regions in many different ways, but it's going to affect everywhere essentially. So this is a graph, just a map just showing the changes in precipitation patterns, not just taking into consideration the breakdown of AMOC, but also in a scenario where we have a doubling of CO2 emissions, because that's likely where we might be at the point of the AMOC starting to break down. So as you can see, we have the wetter areas that will suddenly be in different locations, so further south, and the drier areas. So there's going to be some regions where there'll be an extreme shift, and areas that were previously dry that will see masses of monsoon rainfall throughout the year. And this is just to kind of show what I was saying about how in this part of the world we'll be having an extreme cooling. Again, this is taking into account a doubling of CO2 emissions. Overall, we'll see an extreme warming across the planet, but a cooling in this region. So theoretically, this could mean that you might balance out average temperatures globally, but it's not. But that doesn't mean it's at a nice temperature everywhere, because there are such extremes in different parts of the country, in the world, in this scenario. And this is one of the most depressing graphs that I was ever showed in my master's, but it's just to kind of get a bit of context. So this is a graph that was made to see, or to show, how much time we would have to keep our warming above pre-industrial levels below 1.5 degrees. And this was created following the Paris Agreement, because this was the goal, was keeping 1.5 alive. If we had started to mitigate and reduce our emissions and decarbonize our economy in around 2000, we would have a much shallower gradient, and we'd have much more time to reduce emissions, to stay within our carbon budget. And when this was made, this graph, it was predicted that we had 9 years until we would use up our remaining carbon budget, and from that point on, it would be not possible to stay within 1.5. Slightly redundant now because we have already passed it, but it just shows that even if we had acted like just a few years ago, we already basically had to completely cut emissions straight away to stay within the temperature increase. And we now have reached the point where we're so far past this window of opportunity that the only possible way that some scientists think we can achieve this is to have like negative emissions by pulling CO2 out of the atmosphere. We're just admitting someone, 1 second. Oh, yeah. So this might be the point where you start to panic, and it is kind of scary. But you know, there's still hope for the future. There's still things we can do, because when we talk about tipping points, as we saw at the start of the presentation, we're not just looking at negative ones, because there are positive tipping points that we can use as tools and mechanisms to try and decarbonize our economy quickly and to make real positive change and try to mitigate some of these challenges that we're facing. When they met to do the Paris Agreement, they were saying to stay well below 2 degrees, it would require radical acceleration of action, which we know from looking at the previous graph, as the global economy is decarbonizing at least 5 times too slowly. And it also acknowledged that tipping points where low carbon transitions become self-propelling could be the key to achieving the necessary acceleration. So they're both the tool for our demise, but also potentially for our success if we do them right. And this is just like a simple diagram basically showing how we collectively can become the network of actors, the agents of change to push our world and our systems up to reach a positive tipping point through a variety of interventions until we get here into like happy nature land. And we can do it if we have the right enabling conditions created. And what do these look like? There's a lot of text here because I feel like it's good information to have, but we're not going to go over all of them. But basically just to explain, so we have a list of the enabling conditions. So for example, if you want to implement a new technology or some kind of new system within a community and you want to get it going, you can start by targeting smaller populations. Or if you have a new technology like solar panels, it's finding ways to reduce the price or the cost of it, or the accessibility to a new system. So these are all things to bear in mind when you want to create those enabling conditions. An important part of it, obviously, is to simultaneously enhance the reinforcing feedbacks and reduce the dampening feedbacks. So the things that are going to slow us down from making positive social change, we want to try and reduce those and increase the things that are going to ramp up our efforts. So social contagion is the one that we saw in the dancing video, and we'll look at another example shortly. And one other thing I just wanted to break down is what we call increasing returns to adoption. So the first one here, this is particularly going to apply to the adoption of renewables, which I'll go through in a minute. But the first one is what we call learning by doing. So to put it simply, the more that something is made, the better it can then be made. Like the materials used, the efficiency of it, and they have economies of scale. So the more of something that is made, the more cheaply that it can be made because it's being invested in. And then the third one is technological reinforcement. So the more something is used, the more technologies emerge to accompany that to make it more useful or to improve the product. So as things are invested in, as things are adopted, there are systems or mechanisms in place that help to create a snowballing effect, even if we don't immediately realize it, it just naturally happens. And then this is just showing that there's different types of positive tipping that we can try to implement. And yeah, feel free to kind of go through these in your own time, but just to give some context. So one of the first ones I wanted to talk about, which is positive tipping, that you can argue that we've already seen, is going from, you may be familiar with Greta Thunberg here, who went from sitting down on her own and skipping school on a Friday to protest, to demand that governments start to take climate change seriously, take serious steps to reducing fossil fuels, also trying to convince oil and gas companies to switch to renewables and invest in more sustainable materials. And in a short span, it went from just being her to being thousands of students out there on Fridays. And not just students, this has kickstarted movements with other people in the population as well. And it just keeps growing and growing because of this social contagion, because everyone's like, oh, this is where we're going to make change, because there's enough people doing it and they're actually paying attention to us. And also, people are out there with signs and they're in the media. So that means that people who initially weren't exposed to it suddenly have this information, and they're asking, oh, wait, why are they out on the streets and skipping school? And it's got to the point where Greta has been invited to COPs and major conferences to speak and to be a spokesperson, even as a young person. And I would argue that that is a tipping point that's been surpassed, and it's something that can be adopted across the world and already is being adopted as well. So this is, like, I guess you could say, power of the people, and it is having a real impact in changing political rhetoric and changing policy. Obviously, there's still a lot of pushback and there's still so many problems to be solved, but it had a real turning point. Another thing that was announced a few days ago is the rapid increase in adoption of renewables. And there were several news articles saying that there's early signs of a turning point as renewables have started to edge out coal. World generated more electricity from renewable energy than coal for the first time ever, with the United States lagging behind, but we'll overlook that for now. So renewables are being more adopted, and this is linking strongly back to the returns on the investment that we were talking about earlier. So the economies of scale. So as solar panels and wind turbines have been had more investment and have been created on such a large scale, it's become one of the cheapest ways to generate power, to generate electricity. And this map is just showing, this is a few years old now, but even then it's showing that for lots of countries, it's the renewables which are the cheapest source of new bulk electricity generation. So you not only have it being more affordable and more accessible, but if everybody in your street has solar panels on their roof, then it's like less, you don't think twice so much about having it on yours. You don't think it looks weird because it's like the way to do it, because that's what everyone's doing. And this is going to be really crucial. Obviously, there's a bad side to renewables in terms of like accessing and mining for new materials, and that definitely needs to be acknowledged as well. But in a relatively short period of time, it's become extremely socially acceptable and accessible, which will play a pivotal role in decarbonising our economy and trying to avoid some of these major tipping points that we've been looking at. So just to summarise, our climate is rapidly changing with no immediate indication of slowing down. Global warming is driving some of our major climate systems closer or arguably past their tipping point, many of which are interconnected. And the only way we can now limit warming to well below 2 degrees is through these positive tipping points to accelerate transformative change. Policy interventions and reinforcing feedbacks in societies and technology are already starting to tip us in the right direction for decarbonisation. And these positive tipping points empower us all to become agents of change in the face of these complex challenges. I have some of these, and I just wanted to end, in case anyone wanted some more information, about the Global Systems Institute at the University of Exeter. I referenced a lot. This is a link here for the course that I did, in case anyone's curious to know what it involved, and you can go from there to look at PhD opportunities or research opportunities. I referenced a lot Tim Lenton, who is an absolute legend. It sounds like I'm obsessed with him sometimes, because I am, and he's one of the main brains for tipping points, and he's written many articles and books about it. One of them is here, for example, I strongly recommend reading. He's the founder of the U.D.C.A and a chair in climate change and earth science, system science. And Peter Cox is the current director of the Global Systems Institute and a professor of climate system dynamics and mathematics. So there's also links here to their academic profiles. If you wanted to get in touch with them, ask them any more questions about tipping points or the Global Systems Institute or anything else that they're specializing in. This is just two of the great professors that we had there in the course. But I can share my own details as well if anyone else wants to get in touch with anybody there or learn more about the institute or the course. I'd be more than happy to do that. And that is a lot of talking from me. Thank you so much for listening. I hope you enjoyed the presentation. And if anybody has any questions, please feel free to shout out.
Agradecemos a Sally por esta charla tan inspiradora e interesante que nos permitió comprender de manera más profunda la relación entre los puntos de inflexión y los procesos de cambio climático, así como la relevancia de identificar los factores que pueden orientar estos procesos hacia transformaciones positivas. Su presentación, especialmente con el video de danza que nos mostró al principio, ejemplifica el poder de contagiar actitudes y movilizar acciones colectivas. Nos invita a reflexionar sobre el papel de cada uno y cómo podemos desempeñar en la generación de cambios significativos. Agradecemos también las valiosas informaciones compartidas sobre su grupo de investigación, las posibilidades y oportunidades de colaboración que sin duda abren puertas para fortalecer un intercambio académico entre estas diferentes instituciones en la construcción conjunta de conocimiento. En línea, el profesor Oscar Pisicek plantea una pregunta muy pertinente pues para seguir con las reflexiones. El profesor Oscar nos pues hace la pregunta a Sally: ¿cómo podemos potenciar el incremento de estos agentes de cambio positivo para generar una mayor conciencia ambiental? Sally, how can we empower these positive change agents to generate greater environmental awareness?
Great question. Thank you, Bruna. How can we empower agents of change? I think a really important first step, to be honest, is, like I was mentioning with the impact of protest, getting the information out onto the streets and in the news. I think public awareness is a really important thing, because if you hear if you can hear about this like alarmist news and talking about how the climate is changing, but I think a spread of awareness of not just what's happening, but also what I guess what organizations are already or have already been formed that you can join. I think going out and I guess reaching out to researching what your local climate group is, and even if you don't join them, you can learn about ways that you can make a difference, and you can learn about the science behind it so that you understand it better. So I think awareness and that aspect of education is really, really key, because otherwise you feel a bit lost in the abyss. And I think I'm quoting someone when I say this, but a big part of becoming an agent of change, I think, and maintaining that optimism. I think optimism isn't something that you can just wait to happen to you. I feel like you have to go out and look for it. So you have to go out and find those opportunities to be part of the change, so you feel like you are making a difference. And the more you put yourself out there, and the more opportunities you find, the more groups you join, the more things that you sign your name up to kind of create a poll for things. It's that makes you feel more optimistic and more empowered. And then I think in itself is kind of like a positive feedback, a reinforcing feedback, because the more that you do, the more empowered you feel, and the more empowered you feel, the more that you want to do, and then this enhances the impact that you have. And I also strongly believe in ripple effects. So I think that since I became more involved and informed in sustainability and climate science, and I started to and activism, and I started to ramble on about it, I think word spread, and the people around me started asking me questions and be like, Sally, why don't you shut up about activism? Why don't you shut up about the Greenland ice sheet melting? And then they tell people. So I think there's also a power in the ripple effect. So it's about education, sharing it with those around you, and then you can quickly form a community. And as we've seen, when you do have a collective of people, when you have a community, you can be so much stronger, and you can have so many agents of change creating one larger change, if that makes sense.
Thank you, Sally, so much for your interesting presentation. Muchísimas gracias a todos los que asistieran a esta presentación. Creo que el mensaje que nos queda son las pequeñas acciones que podemos hacer justamente para tener este resultado positivo en términos de cambio climático y en términos de sostenibilidad. Entonces, muchísimas gracias a todos, y con estas preguntas, creo que no tenemos más preguntas en el chat. Entonces, damos por finalizada esta sesión, y pues creemos que quedamos con un mensaje muy importante de este punto de inflexión y de todos los aspectos positivos de pequeñas acciones que en conjunto vamos a llevarnos a grandes impactos en términos de sostenibilidad. Entonces, muchísimas gracias a todos.